So this is the Unit 5 Factor 4 skill video covering how to factor trinomials when the a value is greater than 1. So let's look at our first example. We'll do 3x squared minus 8x plus 4. Okay, note right here with this 3, it is greater than 1, so we can't just do that simple factor chart idea with multiplication to 4 and addition to -8. That 3 is kind of in the way. Okay, so I'm going to just kind of make a note for this one. So note the a value is greater than 1, and in addition to that, it's not a greatest common factor, right? We cannot divide that 3 out of each term. So it's not a GCF. If it was, that would make this problem a lot easier. Okay, so let's look at our strategy here. This is still the result of two binomials being multiplied together. Okay, so this is still the result of FOIL method. And so I know that somehow this originally came from 4 terms. Okay, now in FOIL method, this first term, it never changes. It comes from the first step of FOIL. Okay, and the last term, the positive 4, it comes from the last step of FOIL. Okay, but this middle term, the -8x, it came from the addition of the O and the I steps, right? We've talked about that. And so it actually is a combination of those two terms added together. So to go backwards on this, we're going to start by actually making one of those charts like I did before, kind of that factor chart with the times and the plus. And we have a little bit of a change. Okay, instead of just looking at the 4 at the end in that C spot, right, A, B, and C, we have to bring this A value into play because it's not just a 1 anymore. So we actually multiply these together, okay? So it's the A value times the C value, which in this case is 3 times 4, and we get 12. And that is what goes in this new multiply spot. Okay, we're looking for two numbers that multiply to 12, so the A times the C. And then the addition one is exactly as before, it's just that middle B term, so it adds to -8. Okay, so let's fill in this chart with the right numbers. So two numbers that multiply to 12 and add to -8. Well, that would be -6 and -2. Okay, they multiply to +12 and add to -8. Okay, so the question is, what do I do now with these numbers? Okay, well, these help us fill in the O and the I steps. Okay, so I'm going to bring down the first term, right? 3x squared didn't change. I'm going to go ahead and bring down the fourth term now, the +4. That part didn't change. And the middle term, that -8x, I'm splitting up into these two pieces, the -6 and the -2. So I write it as in one spot, the -6 with an x, and the -2 with an x. Okay, so the two numbers from the chart we use to split up that middle x term into two pieces, and it doesn't matter the order. Okay, so the minus 2x could have been written in the O spot, and the negative 6x could have been written in the I spot. Okay, so we split that middle term. Okay, I'm going to actually write that over here. So we split up the middle term into two x terms. Okay, that's what we did right here. Okay, now we have 4 terms, and I want you to think of like splitting it in half almost and looking at it in 2 groups, the F and the O step, and then the I and the L. And with each of these groups, we're going to factor out the GCF of each group individually. Okay, so remember GCF out front and what's left in parentheses, and then we'll do the same for that second group. Okay, so let's see, in the first group we have a 3 and an x in common, so I'm going to write that here. Okay, and then I divide that out of the first term and I'm left with x, and I divide that out of the second term and I'm left with a minus 2. Okay, now let's look at the second term, or the second group, minus 2x and plus 4. Well, they definitely have a 2 in common, and because that first term starts with a negative, we've talked about taking out a negative as part of the GCF. So we have to take out a negative 2, and then what's left in parentheses is just an x, and then the 4 divided by negative 2 leaves us with negative 2. Okay, so I grouped up the first 2 terms, took out the GCF, grouped up the second 2 terms, and took out the GCF. Okay, so right here I'm going to write take out the GCF in each pair. Okay, and we really just have one final step and we are done. Okay, so now notice that what is left in parentheses in both of our pairs is identical. And this is not coincidental. This should happen, okay? These should look exactly the same at this point, okay? And it's kind of like the common piece in each of those 2 pairs. So I want you to think of bringing these together and writing it once in one set of parentheses. That is one of the binomials, okay, that become one of our final factors. And then, let me grab a different color here. Okay, and then the leftover piece, right, like this 3x out front and the minus 2, okay, those were like the GCFs of those 2 groups. Those actually get put together and become the second binomial, 3x minus 2. So I just kind of smushed them together and made them the second binomial. And this is the answer. This is factored form of our original 3x squared minus 8x plus 4. Okay, so it's x minus 2 times 3x minus 2. If we wanted to double check this, right, we could always do a FOIL method. Okay, make sure that it works. Remember that x times 3x squared, or 3x is 3x squared. X times negative 2 is negative 2x. And then the inner terms, negative 2 times 3x is negative 6x. And negative 2 times negative 2 is positive 4. Okay, just double checking, my like terms combine and I'm left with 3x squared minus 8x plus 4. Okay, and notice this is the original expression that I started with. Okay, so original problem. And so I know that my factored form is correct. Okay, I've undone the multiplication correctly with this answer here. Okay, so this seems to have a lot of steps here, but let's go ahead and clean it up and try it again in example 2. Okay, let's start with 2x squared plus 11x plus 5. Okay, and I'll go through each of those steps again, but a little quicker. So we start with A times C. Okay, in fact, I sometimes call this the AC method because it reminds me to start by doing A times C. Notice again, the reason we're doing this is because there's a number out front for A that isn't 1, and the 2 is not a GCF. Okay, it cannot be divided out from each term. So we start by multiplying 2 times 5. We get 10, and that is what I use in my chart, okay, for the multiply number. So 2 numbers that multiply to 10, and then those same 2 numbers, I need them to add. It's still the middle term, the 11. Okay, so I find 2 numbers that work. In this case, it's 10 times 1 and 10 plus 1, right? So I rewrite this next step. I'm going to have 4 terms in this next step. The first term is just the original first term, okay? The last term, because there's going to be 4 total, the last term is just the plus 5. So notice those are not changing here. But what does change is the middle term, and this is where we split the middle x term into 2 x terms. One uses this 10 and one uses this 1. So we have a positive 10x and a positive 1x, or you could just put plus x. The next step is kind of splitting this in half and treating it as 2 pairs, and we're going to take the GCF out of each pair of terms. Okay? So in the first pair, I notice that there's a 2 and an x in common. And what I'm left with in the parentheses is x plus 5. Okay, I've divided out the 2 and I've taken out 1x. Then I go to the second pair, 1x plus 5. Well, notice they don't have a common factor. There isn't anything in common. So if that's the case, then in this spot, I want you to write plus 1. Okay, like that is the GCF. So I'll just kind of label these. Those were the GCFs of each pair. And notice if you're only taking out a 1, nothing changes, and you're left with still x plus 5 in each term. Well, that is just what we want, because remember, in the parentheses, those should be identical. They are. I know that I'm on the right track, okay? And then I bring these identical binomials together. I write them once. That is one of the binomials in my final answer. And then my second one comes from bringing my GCFs together, and I've got 2x plus 1. Okay, and that is my final factored form. And it really doesn't matter which order these final 2 binomials are in. You could have the 2x plus 1 first and the x plus 5 second. Okay, let me give you another example to try on your own. Okay, go ahead and copy down this example for example 3 and try to work through those steps that I showed as a strategy to factor this trinomial. Okay, here's the worked out steps for factoring example 3. Okay, of course I could always use FOIL method to multiply these back together and make sure I get my original problem, the original expression. Okay, then I know that I would get all of my pluses and minuses in the right spot. Okay, so I'm going to pause the video and I'll ask if you have any questions in this process.